All right, here we are for a Module 7 walkthrough. So if you're watching these videos back to back to back and probably pausing to do your OWL questions in between, props to you. Keep powering through because just as I'm making these right now, I'm doing them back to back and these next 6 questions. Whew. Okay. So classifying amines. Similar to how we classified alcohols in the last video in the Module 6, but like kind of a little different. So we want to look for that amine group. So here I see this amine group right here. And then with the alcohols, we went back to the carbon and then saw how many carbons were attached to that. Here we're looking how many carbons are directly attached to that amine group. So I see a carbon to the left and to the right. So this has got 2 carbons attached to it for a secondary. All right, this is a good one. So here's my amine group. I have a carbon here, and it looks like it's a secondary because of the carbon to the right. But this 2 out here really implies that there's 2 ethyl branches and that this molecule, this is just the condensed formula for this. All right, so there's really 3 carbons, making it a tertiary. There's also 3 carbons here, 1, 2, 3. So this is also a tertiary. All right. I'm not going to do the second example of that one. All right. Drawing amines. Drawing. So if you're starting here and you didn't watch Module 6 with my drawing, I recommend drawing it on a piece of paper first before you try to draw it in the program. So I know I have an amine group present. Couple reasons. Because I know that that's what the question's asking for. Also because it has the ending anamine. All right. So I know that that's going to be in there at some point. First, I'm going to start by looking at how many carbons there are in the main chain. Prop. So there's 3 carbons in the main chain. And I know that one of them has an amine group. Because amines aren't one of them that always falls at carbon 1, I need to look at the name to know what carbon it's coming off of. And so this 1 is telling me that it's coming off of carbon 1. So I have a nitrogen and then so many hydrogens. And the program's going to take care of that for us. So that's fine. So 1, 2, 3 carbons and my amine group coming off of carbon 1. So to draw, again, if you're watching this video before you watch Module 6, you're going to hit the single bond tool. You're going to hover over the carbon that it already starts you off with, hit it once. That's going to give you 2 carbons. You're going to hover over the carbon you just dropped, hit it another time. That's going to give you 3 carbons. The thing with this program is, though, you always draw out hydrogens, everything is hydrogens, and then you come back and override later. So I'm going to hover back over my first carbon and put a single bond to another carbon. Then I'm going to come up here. It's already preset for the oxygen, but I'm going to come to the N here, which means nitrogen. And then I'm going to hover over that last carbon I just made to make it a nitrogen. All right, so now it looks like the molecule. Ta-da. All right, next one. This one's a little bit more, I don't know, complicated. All right, so amine, prop, so 3 carbons in the main chain. Now this time, this amine is coming off of carbon 2. So amine group here, if this is 1, 2, 3. The good thing about working backwards from getting a name and then drawing it is you get to decide which is carbons 1, 2, and 3. You can number right to left or left to right, because the molecule hasn't been drawn yet. All right. So the next, I have a methyl group. So that's a 1 carbon branch also coming out of carbon 2. So my molecule is going to look something like this. So I'm going to start by grabbing that single bond tool and making the main chain. So 1, 2, 3. There's my main chain. I'm going to hit up for this guy, override that so that way it becomes my nitrogen or my amine group. I'm going to come back to the single bond tool, hover over this guy, and that throws out another branch to be my methyl branch. There we go. All right, physical properties of amines. So here we have an alcohol group. Here we have an alkane and an amine. So alcohol is going to be the highest in this group, then amine, and then alkane is the lowest. There we go. All right, and I'm not going to do a second one of those. We've done a lot of examples of those. All right, naming amides. All right, this is usually the toughest one because really, to master naming amides, you have to get all four of them right. Or you have to get two of them right to get one question right. And there's two questions in each thing. So you have to get four of them right, basically what I'm trying to say here. And some of them, it seems to have a really small question bank, and it usually pops you something like this. So I think we'll do all three for this one, just because it's got such a small question bank that you're probably going to get one of them that I showed you. All right. So the amide group. All right. Right here it is. In fact, that first molecule is only an amide group with one carbon. So this is meth and amide, right? One carbon, no branches, nothing else. Here, can I highlight it? No. All right. Here's that same group, that meth and amide. Only now I have a branch. All right. It's a branch and not a continuous chain because the nitrogen breaks it. It's a continuous carbon chain. Never this nitrogen would break that chain. And we, instead of going this way to make our longest chain two, we need to include that carbon that has the functional group. So this is always my carbon one. All right. So this would be a two carbon branch coming off the nitrogen. So a two carbon branch is an ethyl, and it's not coming off a carbon in the main chain, so we can't give it a number. This is when we use the N. So it's going to be N, ethyl, meth, because it's still one carbon in the main chain, and amide. Crazy. All right, we'll do this one. All right. So here we have our amide group. So that's going to be our carbon one. So we have 1, 2, 3, 4. All right, so this is going to be a bute and amide. Amides always come off of carbon one, so you never need to tell the audience what carbon it is. And then off of carbon two, we have a two carbon branch. So two ethyl, bute, and amide. With the second one in these questions, it usually builds off of what we already have, but it throws another branch the um, on the N group. So here, basically we have the same molecule that we had above. So this is still going to be there, but now I've added another branch and I've added this ring with an extra carbon here. So I'm going to be honest, I always have to check my notes for this because there's a phenyl and a benzyl. I believe a phenyl is when it directly goes, so say this is nitrogen, and it directly goes into the ring. And I believe a benzyl is when it has this carbon, the extra carbon, and then goes back and forth. I always get them flip-flopped. So we're going to see what happens here. But basically now this is my branch. Whatever one this is, which I believe it's a benzyl, we're going to throw in as N-benzyl. So B comes before E in the alphabet. So that branch is going to come first. N-benzyl, 2, ethyl, bute, and amide. Whew. I was right. Crazy, right? Okay, let's do another example. All right, so in the first one, here's our amide. It's carbon 1, carbon 2, carbon 3. No branches. So prop because it's 3, and amide because there's an amide functional group. Next one, at its core, it's still that prop and amide, but now we have, oh, I'm so glad we got this one. This is a functional group by itself. This is an isopropyl group. It looks a little bit different than when I drew it on your functional groups, but if you get this in your owls, it's an isopropyl group. So this is N, because that isopropyl group is coming off of carbon 3. I'm sorry, coming off of the nitrogen. Prop again, because there's 3 carbons in the main chain, and amide. What did I spell wrong? 1, 2, 3. It's definitely isopropyl. What did I do wrong? Prop and amide in isopropyl. Okay, we'll just see what it wants. Isobutyl? Oh man, I did not know that existed. Okay, well, if you get this one, I lied, it's not isopropyl, it's isobutyl. Oh my God. Okay, well, hopefully this helps you if you get that one. All right. These ones can be nasty depending on, usually this one is harder. So we'll go through a few examples here. So in reactions catalyzed by enzymes, only the rate of the reaction changes. The reaction rate increases. I believe that's true. Okay, enzymes can be distinguished by stereoisomers. Ooh, what? We did not talk about stereoisomers. I'm gonna go with false. Okay, the cool thing about these gave me an error, so it must be true. Oh, here's our, okay, A plus B. Okay, so for the reaction A plus B equals C, the concentration of C when the reaction goes to completion will increase if an enzyme is used to catalyze the reaction. False, it will just go faster. Yeah. Okay. Now this one can be hairy. So hopefully I can help you out on this one. All right, so here we have, it looks like it's the induced fit model because it's not a perfect shape. So this is definitely the induced fit. Okay, we didn't talk about this, but it's not allosteric. Allosteric's when it has multiple active sites, so it's not that. It's a favorable interaction. Yeah, I believe it's favorable. It forms catalytically. I believe it's this. Catalytically competent. Yes. Yes. And it's not the lock and key, so we're good there. Oh yeah. Okay. Let's do another example. All right, suppose an enzyme and substrate obey the lock and key model, which would be true. Only one substrate can be converted. Yes. Rigid. Yes. No. Rigid. Yes. Ooh. Let's try. Oh, wait. The entire enzyme doesn't need to be rigid, only the active site. Let's try that. No. Okay, I guess it's only the active site must be rigid. I'm assuming there's another correct one in there because usually it's not just one. Okay. Here we have this one again. This looks like a lock and key. It's gonna conversion. It's gonna convert. It's not the induced fit. It's not allosteric, and it has an active site. Oh my gosh, I hate these questions. Okay, let's try just these two. What? Okay, let's retry this group. Okay, so we saw this one. It's the induced fit. It's not allosteric because that's multiple active sites. It's favorable. And it has the formation of this complex. Yes. All right. The active site must be rigid. I guess this must be true. There we go. All right, so if you get that one, there you go. All right, let's try this one again. This is the lock and key. It's not allosteric. I guess it does show the interaction. There we go. Why is it not the conversion of substrate to product? Whatever. All right, there we go. There's a correct answer if you get that group. Kind of stupid questions. All right, we did it. We can stop this.